Oh man, if you thought that last video was hot, this one is all about temperature. Exothermic and endothermic reactions. Well, not really temperature specifically. You know, other chemistry teachers might get mad at me for saying that. I don't know that other chemistry teachers actually watch this, but okay, anyway. It has to do with heat, which is a little different. So let's read. Energy is the capacity for doing work, or supplying heat. Unlike matter, energy has neither mass nor volume. So energy, no mass, no volume. So what is it? Energy is detected only because of its effects. A hot water pot, a speeding car, an explosion. So I guess those are all things that have energy. Thermochemistry is the study of how energy changes in a chemical reaction and changes in state. So state, I know that's not like Illinois, California. No, that's like gas, liquid, etc. Right, solid. The energy stored in bonds is called chemical potential energy. That reminds me of physics, potential energy. While the energy from moving atoms is called kinetic energy. That also reminds me of physics. Reactions either give or take energy when they react. Okay, so two options, give or take. This heat, Q, so I guess Q is the variable for heat. Seems kind of a silly variable. Why not H? Is called the heat of reaction or the enthalpy of reaction, delta H. Read delta H. Oh yeah, delta, that little triangle is a Greek letter, delta. So enthalpy is delta H. Heat is Q. Okay. At constant pressure, the enthalpy of reaction is equal to the heat change as well. So the delta H, the enthalpy, is equal to the heat change is Q. Thus Q and delta H can be used interchangeably. So they can be used, either one is the same thing, I guess. In more advanced chemistry, this is not always true. Okay, so I guess for this class, Q equals delta H, but for other classes, maybe it doesn't, but for this one it does. Okay. If the heat of reaction is negative, that means the system has lost energy and the reaction is exothermic. Heat is exiting the system. So exothermic means heat leaves. If the heat of reaction is positive, that means the system has gained energy and the reaction is endothermic. Heat is entering. So endothermic equals heat entering. Endo, in, exo, exit, entering. Okay, what's this? So surrounding system, heat going in, that's endothermic, delta H is greater than 0, so that's positive. And then surrounding system heat going out, that's exothermic, delta H is less than 0, so that's negative. Negative. And let's look at this. So this is a reaction. Endothermic 2Ki goes to I2 plus 2K. Delta H, okay, positive, so that's like this one right here. And then exothermic, that's like this one. CaCl2, Ca2 plus, 2Cl minus. Delta H is negative, so heat is leaving the system. So think up some examples of exothermic and endothermic processes. Short, sweet, to the point. I'll see you in class.